Hello everyone, myself Lanam Limboo of Namchi Government College, South Sikkim, roll number 21NSO303, third semester, Physics Department. So here I would like to introduce my topic on Stern-Gerlach's experiment. So introduction, the Stern-Gerlach experiment was meant to test Bohr Sommerfeld hypothesis that the direction of the angular momentum of a silver atom is quantized. The experiment was performed several years before Leckant and Goldsmith formulated their hypothesis of the existence of electron spin. So, here diagram. Stern-Gerlach experiment: silver atoms traveling through an inhomogeneous magnetic field and being deflected up or down depending on their spin. That is number one furnace. Number two, beam of silver atoms. Number three, inhomogeneous magnetic field. Number four, classify unexpected result. And last one, number five, observe result. The Stern-Gerlach experiment demonstrated that the spatial orientation of angular momentum is quantized. Thus, an atomic scale system was shown to have intrinsically quantum properties. In the original experiment, silver atoms were sent through a spatially varying magnetic field which deflected them before they struck a detector screen, such as a glass slide. Particles with a non-zero magnetic field are deflected due to the magnetic field gradient from a straight path. The screen reveals discrete points of accumulation rather than a continuous distribution. Owing to their continuous spin, historically the experiment was decisive in convincing physics of the reality of angular momentum quantization in all atomic scale system. And the principle, uh, a beam of potassium atoms generated in a hot furnace travel along a specific path in a magnetic two-wire field. Because of the magnetic moment of the potassium atoms, the non-homogeneity of the field applies a force at the right angles to the direction of their motion. The potassium atoms are thereby deflected from their path by measuring the density of the beam of particles in the plane of detection lying behind the magnetic field. It is possible to draw conclusion as the magnitude and direction of the magnetic moment of the potassium atoms. So theory, Otto Stern and Walter Gerlach devised an experiment to determine whether particles had any intrinsic angular momentum in a classical system such as Earth orbiting the Sun. The Earth, the angular momentum from both its orbit around the Sun and the orbit around its axis. The experiment sought to determine whether individual particles like electron having any spin angular momentum. If the electron is treated like a classical dipole with two halves of charge spinning quickly, it will begin with the process in a magnetic field because of the torque that the magnetic field exerts on the dipole. If the particles travels in a homogeneous magnetic field, the forces exerted on opposite ends of the dipole cancel each other out and the motion of the particles is unaffected. The experiment is conducted using electrons and electric field of appropriate magnitude and oriented transverse to the charged particle path is used to compensate for the tendency for any charged particle to or curl in its path through a magnetic field. And the fact that electrons are charged can safely be ignored. The Stern-Gerlach experiment can be conducted using electrically neutral particles and same conclusion it reaches. It is since it is designed to test angular momentum only, not an electrostatic phenomena. So sequential experiment. Here is a diagram which shows sequential experiments. If you combine some Stern-Gerlach appropriate, we can clearly see that they do not act as simple selectors but after the state observed according to quantum mechanics laws. So, significance. The Stern-Gales experiment was initially regarded as a crucial test between the classical theory of the atom and the Bohr-Sommerfeld theory. In a sense, it was because it shows clearly that sparse, spatial quantization existed, a phenomenon that could be accommodated only within a quantum mechanical theory. Application. Many theories have been put forward at one time or another to explain the chemical activity of active nitrogen and the mechanism of the production of yellow afterglow. Reunion of nitrogen atoms to form molecules, metastable molecules, and interaction between atoms and molecules have been drawn upon to explain the afterglow. At the time, the work describes in the present paper was Hammerstein. The theory holding the field was was that of Spooner. According to this theory, the normal nitrogen atoms collide in a triple collision with a normal nitrogen molecule, with the resultant formation of one normal nitrogen molecules and one excited molecules.